Today we're going to learn about column elution. We've already talked about equilibrating the column, loading the sample to the column, and the final step is eluting the column. Again, we're doing the elution, and next time we're going to do some activity assays. We're also going to pool the fractions, and pooling the fractions means that we have the protein of interest that we want, but it's going to be spread out within maybe 5 or 6, maybe 8 fractions. We put those fractions together and we actually concentrate the protein. You have two types of gradients that you can work with. You can either work with a stepwise gradient or a linear gradient. And the difference between the stepwise and linear gradient is the step uses maybe 3 or 4 different concentrations of which they're eluting with. And the linear gradient provides a greater discrimination in the elution profile, meaning that you can separate more of these proteins with a linear gradient more so than a stepwise gradient. And we're also going to learn how to properly use a fraction collision. So these molecules are going to be eluted based off of their overall charge. You see here is a depiction of a typical ion exchange column and the proteins which are bound in the column. So at the top, you see the proteins of more highly charged molecules are more tightly bound. So, and then you have other proteins which are moderately charged. And so they interchangeably equilibrate between being bound to the resin or flowing with the mobile phase, which is going to be the buffer. So, and then you have less charged molecules which bind less strongly to the beads, and they more readily diffuse within the buffer and flow out of the column first, which both of them take advantage, like we talked about last time, of the same chemical properties. The stepwise gradient is fast, it's simple, but it's not very discriminating, meaning that you won't get a very good separation of these proteins. It usually causes most of the proteins to be eluted at once. At some particular concentration, most of the proteins are going to come off. And this is commonly used in a lab if you want to get a quick purification done and you already know where your protein comes off. But when you're dealing with samples where you don't know where your protein is going to come off, it's better for you to use the linear gradient. So the linear gradient is the buffer composition is changed progressively or gradually, and it's technically more complicated because you have to make this gradient. But it's far more discriminating, and the proteins are eluted off the column based on their charge or PI. So now you can really take advantage of this property.